Alright, hello everybody, it's Miss Summers with your notes today. On humidity and dew point, we want to see what the relationship between humidity, dew point, and temperature is. So we're going to look at what each of these things are, how we measure them, and then some overall general trends and patterns. So let's begin with what is humidity. Now, if you've lived in North Carolina for any period of time, you're probably familiar with humidity. It's how much moisture there is. So how much water vapor or gaseous water is in the air. Alright, so a little cartoon to go with this. This little fish bought a dehumidifier, which isn't a good idea because dehumidify means you take the water out. Now, there's two types of humidity, absolute and relative. We're only looking at relative humidity today. And it is a ratio. A ratio is like a fraction. So it's the amount of moisture in the air compared to the amount of moisture the air can hold at that given temperature and pressure. So because it's a ratio, it's expressed as a percent. This is what the weather person on TV is probably talking about when they talk about what the humidity is today. It's going to be something like 50% or 100% or something like that. It's another fish humor. All right. So relative is a ratio. That's what relative actually means. You have to compare it to something. All right. I'm going to give you a second to write this down. Pause it if you need to. You'll note I put 4 little stars on this slide because this is super important. This is the one of the main takeaways today. So the warmer air is, the more water vapor it can hold. Which on the flip side of that, colder air can hold less water. It's because cold air doesn't have as much energy. Now what that means throughout the day, early in the morning is usually when our lowest temperature is. And because the temperature is so low, normally at that time, the relative humidity for the day is going to be highest then. And this is what causes dew. Dew is liquid water. It's water vapor that condenses to dew. So as it gets warmer throughout the day, if the amount of moisture in the air doesn't change, as that temperature increases, the amount of water the air can hold increases, which makes the overall relative humidity decrease. So higher temperatures, if the amount of water in the air doesn't change, causes the humidity to go down because warmer air can hold more. Now, let's take a look at this statement that this person would rather be in the desert than in North Carolina during July. Now, in the desert it gets really, really hot. We know that. So why would you rather be there? Has to do with the humidity. Here in North Carolina, during the summertime, the air can get really humid, like 90% relative humidity. That means the air is 90%, holding 90% of the water that it can hold. At that humidity, sweat does not evaporate. And because sweat doesn't evaporate, it makes us feel hotter than we actually are. But in the desert, deserts are very dry. The air doesn't have a lot of moisture. So even though it's hot, it feels cooler because our sweat can evaporate. And sweat evaporating makes our bodies cool down. That's why we do that. That's why we sweat. So we're very sensitive to humidity. If humidity is high, that can be quite dangerous for us because it prevents us, or it keeps our sweat from evaporating. All right? If we can't do that, we can't maintain our body temperature, and that can be very dangerous. Give you a point of why you should care and why, like how dangerous it can be. You can overheat. This is what happens if you overexercise, especially when it's quite humid outside. You can get heat stroke, and that's pretty bad. So here's an idea of how we can overheat. Let's say it's 90 degrees, which it can often get in North Carolina. If the relative humidity is at 65%, to our bodies, it feels like it's 106. And 106 is hotter than we're supposed to be. We're supposed to be 98.5. So even though 90 is less than our body temperature, we can still overheat there. All right, and the hotter it gets and the higher the humidity, the more dangerous it is, which is why they ask you to go check on your neighbors and your pets and things like that. So let's talk about how we measure relative humidity. It's really cool. We use a Sling Psychrometer. So a Sling Psychrometer is an instrument. You can make one of these at home. You don't actually have to get one. All you need is 2 identical thermometers and something to attach them to that you can sling around, kind of like a string. So I make these using a Gatorade bottle, some rubber bands to attach them, and then I tie a string to the top. So these thermometers, one is dry. I'll let that go. One is dry, and that's going to give you the current air temperature. The other one has this paper towel on it with some water. And that water is going to evaporate as it slings around, as it gets spun around. And that's going to absorb heat, and that's going to cause this thermometer to go down. So basically, the humidity controls how much of this water evaporates. If it's really humid, not a lot of water is going to evaporate, and this thermometer isn't going to change as much. If the air is really dry and the humidity is low, a lot of this water can evaporate, and this thermometer will drop a lot. So now that I have those 2 temperature readings, one on the dry bulb, which is just regular temperature, and the one on the wet, which has the paper towel, I'm going to look at a relative humidity table. So the relative humidity table, you look at this side first. This is your dry bulb temperature. I'm going to write this down or circle it. Dry, so I don't have to do anything with that number. And then I need to find the difference. Difference means subtract. And where those 2 intersect is your relative humidity. So let's do this example. Dry bulb is 22. That would be right here, highlighted in blue. The wet bulb is 16. Now you'll note there is no 16 over here. I want the difference. So I'm going to do 22, writing with my mouse, it's not very easy, minus 16 gives me 6. So that's where I got this number from. And go straight down and straight over, and that's my answer. That's what I'm going to do. So let's do some practice. I'll do one with you. So the dry bulb on this one is 12. So I'm going to go to dry. I'm going to go to 12, which is right here. And the wet bulb is 7. Don't go to this one. I want the difference. So 12 minus 7 is 5, which you are, of course, already knew. So I'm going to go here. I'm going to go down and over, and my answer is 48%. So you try this one. 22 is the air temperature, or the dry temperature. Wet bulb is 20. So here's 20, or not 20, excuse me, boop, boop. 22, the difference is 2, go straight down, go straight over, 83. Now, do this last one yourself, and you should have gotten the answer 65, because 10 minus 7 is 3, there's my difference, there's 10, 3, 65. All right, so here's another slide with some stars on it, which means this is very important. This is the main takeaway today. If the wet bulb temperature and the dry bulb temperature are the same. So, example, let's say the wet bulb temperature is 10 and the dry bulb temperature is 10. If they're the same, that means my difference is a big fat 0, which is here. If they're the same, that means humidity is at 100%. So if I look at this chart and I go all the way down, 100%. The air is so saturated, if the air is at 100% relative humidity, that means it can't hold any more water, and none of the water from the psychrometer can evaporate. The bigger the difference is, so if I go down here, the bigger the difference is between the dry bulb temperature and the wet bulb temperature, the lower the humidity is. So you'll get a small humidity. The smaller the difference, so if your dry and wet bulb temperature are 1 or 2 degrees different, that means it's really humid, like 90, 80%. So very important. That's an easy way to tell, to give you an idea of what the humidity is going to be, even if you don't have one of these charts. So now that we've talked about relative humidity, we've looked at the charts, we can figure it out, we know how it's measured. Let's look at dew point and what that is. Give you a second to write that down. Pause it if you need to. Dew point is the temperature that the air would need to cool to in order for water vapor to condense into liquid water. Cool to condense the water vapor into liquid water. In other words, the point or the temperature you would need to be to make dew, because dew is liquid water. All right? Now, what's cool about dew point and relative humidity, I use the same instrument. I use a Sling Psychrometer, so that dry and wet bulb temperature. I just have a slightly different chart. So let's do the same thing, except for this one. So if my dry bulb is 12 and my wet bulb is 7, find the difference is 5. Beep, difference is 5, dry bulb is 12. This is going to be a temperature. Go straight down. So my dew point here is 1 degree. That means the air would have to drop 11 degrees to get to 1 in order for dew to form. All right, let's try another one. 22 and 19 is going to be a dew point of 17. So again, 22 minus 19 is 3. So there's 3. Let's find 22 right there. Oh. Oh no, I have made a mistake. There is a mistake. This should not be 17. Nope, 8 should be. LOL. I'm looking at the wrong thing. There you go. So, exact same way. It's just the end number is going to be meaning something else. So, our last point that we're going to make before I let you go and do your independent work is our last big pattern that I want you to recognize. The closer the dew point is to actual temperature, the more humid it is. The greater the difference between dew point and actual temperature, the less humid it is. So if I have a dew point, let's say it's 60 degrees outside, that's going to be temperature. If my temperature is 60 degrees, but my dew point is, let's say, 59, so it's only a degree different, that means that it is very humid. That is what that means. The closer these numbers are, the more humid it is. The further apart they are, the less humid it is. All right, so nice low dew points means not humid. It'll be a nice dry day. High dew points, it's going to be really muggy. All right, if you have any questions, you need to bring them to me at this time. If you need to go back and look over any of the practice problems, please feel free to do that. If not, come check with me, and you may get started on your work for the day. Thank you.